Okay, so to complete our study of differentiation and inverse functions, we're now going to focus on taking the derivatives of the 6 inverse trigonometric functions. Yesterday, we made some observations about the slopes of inverse functions. We discovered that they were reciprocals. The input of f, when you find that slope, it was the reciprocal of the inverse at its output. Okay? Today, we are going to continue to think about inverses, but expand our view to trigonometric functions. So, what I'm going to do is we're going to develop the first 3, then I'm going to just tell you the other 3, because then you could really develop them the same way. So, if y equals tangent x, and I want to switch x and y, so now this represents the inverse, okay? And if I could solve for y, I would be able to know the inverse function y in terms of x. So I'm going to first take the derivative of both sides using implicit differentiation. So this is 1 equals, what's the derivative of tangent? Secant squared times dy dx. I will divide by secant squared y, and that's dy dx. So the derivative of the inverse is 1 over secant squared y. All right, well, we want this in terms of x, okay? So I'm going to develop how we're going to get there. So if you look at this triangle to the right, I have y is my angle, and the tangent y is equal to x, because this is what we got. Remember, we said tangent y equals x. So what would be the missing side of that right triangle that's x1? How would you find the missing side? Pythagorean theorem, right? You're going to do a squared plus b squared equals c squared. So that would be x squared plus 1 squared equals c squared. So c is the square root, and let me just put it in the form that we're going to see it. So the missing side is the square root of 1 plus x squared. Now, let's use SOHCAHTOA to find the cosine of y and the secant of y. Then this is all going to make sense in a moment, okay? So stay with me. So cosine of y would be 1 over the square root of 1 plus x squared. So then what does that make secant y? Square root of 1 plus x squared. Oh, so look at this. Now letter E, let's go back to our dy dx. Okay, let's go back to this dy dx. And can we substitute that secant y is the square root of 1 plus x squared, and that's squared. And I can simplify that as dy dx equals 1 over x squared. And I want you to stop and think for a moment. This is the derivative of what? What did we find? The derivative of what? The inverse, right? Because I switch, when you say tangent y, that represents the derivative. This represents the derivative of inverse tangent x. All right, so let's try this again for the sine function. All right, so if y equals sine x, what's the first step to finding the inverse of this function? Yeah, okay, so we're going to switch x and y. Now we're going to differentiate both sides of this to solve for dy dx. So this would be 1 equals, what's the derivative of sine? Cosine, so that's the cosine of y, dy dx. So dy dx is 1 over cosine y. In the triangle below, I am using that the sine of y, because that was our inverse in part A, I have sine y equals x, or x over 1. All right, what's the missing side? If you do Pythagorean theorem, what's the missing side of that right triangle? Good job, the square root of 1 minus x squared. Then what is the cosine of y? Think of SOHCAHTOA. Good job. So now, let's go back to our dy dx and replace cosine y so that it is in terms of x. So this, in fact, is the derivative of y equals inverse sine of x. All right, I'm going to pause, and I want you to try the third one using the technique I just showed you in number 1 and 2. See if you can get all the way through it to determine the derivative of inverse cosine. I just did part A. Write the inverse equation. To write an inverse equation, you switch x and y. So I wrote x equals cosine y. Now differentiate both sides and solve for dy dx. So 1 equals negative sine y times dy dx. So dy dx equals negative 1 over sine y. Now in the triangle, because our inverse equation was x equals cosine y, that's why I put the y as my angle, and cosine is adjacent over hypotenuse, x over 1. So what's the missing side of this triangle? There you go. Then what is the sine of y? It's the square root of 1 minus x squared. So dy dx is negative 1 over the square root of 1 minus x squared. All right, so in these boxes, there are 6, and in green, these are the first 3 we found, and then there's the other 3. You could solve them the same way, I just don't have time to do all 6. In blue, that's with the chain rule. So if there's some sort of stuff inside your inverse trig function, all it does is add a derivative of the inside on the top. That's the only difference. You do need to memorize these. Okay, you do need to memorize these. So we're going to add them to the yellow sheet and get working. All right, example 1. So I'm going to do the long method, and then after that, we're going to try to remember the formula. The nice thing is, if you're on the My Quiz or test, you can always develop it. Okay, you can always develop it from switching x and y, drawing a triangle. You can figure it out. And I would rather build you that way than memorizing, but it does become, I'll tell you, arc sine, arc cosine, arc tangent are the most commonly seen. I don't know that I've ever seen arc cosecant or arc cotangent on the AP exam. So, just saying. All right, so here we go. I have right now, I'm going to show you the long way to figure this out, and then we'll try to use the formulas. So, if I have y equals arc sine 2x, this is the same thing as saying the sine of y equals 2x. This is just going back and forwards from inverse, taking this, you could take the sine of both sides. So then I could do implicit differentiation. Then my angle is y, sine is 2x over 1, and that's the square root of 1 minus 2x squared. And let me tell you something, they're going to put this in my homework tonight. It's hilarious, or I think it's hilarious. But one of the common wrong answers is that students will write 1 minus and just have a 2x squared. They'll forget to square the 2 out front. Okay, that's going to be the most commonly wrong answer on a multiple choice. So then my dy dx or y prime is 2 over the cosine of y is the square root of 1 minus 4x squared. You may always do them this way, okay? You may always do it this way and not ever memorize those formulas. That is absolutely fine. Letter B, I'm going to do this one with the formula, okay? The derivative of arctan of u is u prime over 1 plus u squared. Okay, that's my formula. And it's just above, but I like to write it again and again. It just helps me remember it. And every year I do have to rememorize these. I do know them, but I just need quick refreshers because they're not used a ton. What is u in this problem in part B? 3x. So what I also like to do is I like to identify u and do u prime. So then my derivative is 3 over 1 plus 3x squared. So do you see how that's way easier than the long way? It's just way faster. All right, so what I'd like you to do is I'm going to give you a head start. You choose long way or formulas. Long way or formulas. Whichever way you want to do it, and I want you to try C and D. Yeah, sure. You have to go from that angle wherever you place it is the opposite of it. It doesn't matter. It's over here. Sorry about that. Yeah, thank you. All right, I'm going to try letter C just to make sure we're doing okay. My u is the square root of x, or x to the 1/2. Then u prime is bring down the power, decrease the power by 1. So the derivative is u prime over 1 plus u squared. So that's 1 over 2 square root x over 1 plus x. Now this would very likely be multiple choice, and there's no way that's going to be my answer. So what this means is I have 1 over 2 square root x times 1 over 1 plus x. So that's 1 over 2 square root x times the quantity 1 plus x. So we do need to be careful and comfortable with simplifying. I strongly, strongly recommend you try to simplify all of your problems, because most often there will be multiple choice and it'll be simplified. So if you keep stopping, you are allowed on a free response, but more of them are going to be simplified on multiple choice, and you will be setting yourself up for difficulty if you're not practicing. All right, I'm going to pause in case you haven't finished letter D yet. All right, so here's your formula. It's u prime over absolute value of u, square root u squared minus 1. So u is e to the 2x. So du is e to the 2x times the derivative of that. So that's 2e to the 2x. So that's 2e to the 2x over absolute value e to the 2x, the square root of e to the 2x squared minus 1, right? We good so far? Oh, nuts. Thank you. I was like, wait, something's wrong here. I did something wrong. Okay, thank you. Yep, sorry, let me back it up. My daddy taught me good. Remember that one? So thank you. All right, yeah, I lost it. Guess what? If you have a quantity squared, what's the outside function? Yeah, you have something being squared. So guess what? I have to do the chain rule in here where I bring down the power, decrease the power by 1. Now I'm doing that derivative of the inside, which is the derivative of inverse secant, which would be u prime over the absolute value of u times the square root of e to the 2x squared minus 1. Thank you. Yeah, I missed that little 2 on the outside. So that's 4 e to the 2x inverse secant e to the 2x. Now let's stop and think here a minute. I haven't, and they would not mark it wrong if you left the absolute value of e to the 2x. But what we know, and I've been doing exponentials with my algebra 2, and I like to do my arms with my graph. You understand that e to the 2x looks like this? Okay, it has this general shape, and it has a horizontal asymptote of y equals 0, or the x-axis. So e to the 2x is always positive, right? So those absolute value symbols are no longer needed. Now, if it had been x cubed, I would need it. If it were x squared, I would not need it. Does that make sense? Like, so just think about that. So I'm going to drop the absolute value. And then what happens when you take e to the 2x and square it? That's e to what power? 4x. That is my ugly final answer. Yeah. Oh, yeah. Yeah. Let's do that. So I have an e to the 2x in the top and the bottom. Yeah, I did that on my paper. If you can reduce, we reduce. There we go. Nice catch. All right, example 2. Of course, we can't finish notes without doing an equation of a tangent line. We always do that. So it says find the equation of the tangent line of the curve y equals arc sine x at the point where x equals radical 2 over 2. So let me pause and let you try this. Now with your newfound knowledge. Ooh, and then this will circle back to our warm-up today, where you are going to have to evaluate arc sine of radical 2 over 2. I was trying to set you up for success today. And while you're finishing this, and I'm trying to be patient, tonight's homework. Oh no, a murder has been committed. Peppa Pig has been found dead, and the police have no leads. It is up to you to solve this mystery. Solve each of the following multiple choice questions by taking the derivative of each inverse trigonometric function. Use the space to the right or just below each problem to show your work. This is an exception to the rule. You do need to show your work on this. The correct answers will reveal the details of this heinous crime. It is hilarious. I told Mr. Chandler I put him in as one of the murder suspects. I put myself in there too, but for another option. Thank you. All right, so the derivative is the slope. So arc sign would be, and that's just x, so it's 1 over the square root of 1 minus x squared. And I'm going to plug in. Now, do you recognize that square root 2 over 2 is equivalent to 1 over square root 2? Okay, because that would be easier to square than square root 2 over 2. So, did you get a slope of square root 2? Yeah, Kai? See it? Okay, now I need the y-coordinate. I need the y-coordinate. So I'm really asking myself, the sine of what angle gives me radical 2 over 2? So what is that? Pi over 4. So my point, and it does not matter if you change radical 2 over 2 to 1 over square root 2. That is absolutely fine. So now I'm ready to do point slope. So I had y minus pi over 4 equals square root 2 times x minus, oh, it might be fun to make it 1 over square root 2. And just for funsies, let's put it in y equals mx plus b form. Ah, I don't know why I just did that. I do that. I do weird stuff sometimes. That's square root 2 times x. Would you get square root 2x minus 1 plus pi over 4? I mean, of course, if it's free response, point slope, but they like to do that on multiple choice.